This is Dr. Dibya and discussing the digital image processing lectures. And today our topic is run length encoding. So this is the kind of data compression or image compression techniques that we have already discussed about the data compression techniques in the last lecture. You'll find the link for the previous lecture in the description box. So go through it. Now, run length encoding is a form of lossless data compression in which runs of data, and you have to note it, very important. What do you mean by run? RUN. Run means sequences in which the same data value occurs in many consecutive data elements. I'm repeating again. Run means sequences in which the same data value occurs in many consecutive data elements are stored as a single data value and count rather than as a original run. Okay, so run plays the important role in case of, or we can say that the vital role in case of run length encoding. And this is most useful on data that contains many such run. As for example, simple graphic images such as icons, line drawing, animation, etc., they fall under this type of encoding technique where we can apply the run length encoding. And it is not useful with files that don't have many runs, as it could greatly increase the file size. So if you have some files where there are no repetitions of sequences, that is, there are no many runs, then we are not going to apply RLE. So let's take an example. For example, we consider a screen containing plain black text on a solid white background, and there will be more many long runs of white pixels in the blank space and many short runs of black pixels within the text. So a hypothetical scan line would be representing a black pixel and W representing white might be read as, you got it. What I mean to say means, suppose you are considering a screen where we have plain black text on a solid with white background. So obviously white number will be what? More than B. So we have a possibility of, not possibility, that is a very direct case, that we'll have more runs with respect to white than B. So let's consider this one. You see, there are many W's. W stands for here. Although you'll see the red color, actually I'm representing in red just to show you the example or very clearly. But here W represents white, and this B, you see that B represents black. Okay, so this is the particular line. Now with a run length encoding data compression algorithm, this will be converted into what? In the first case, you'll find 12W. Take a screenshot and take a measure of that. 12W. Then we have 1B. Then again we have how much? 12W. Then we have 3. Okay, 1, 2, 3, 2W. Okay, 3B. Okay, 3B. Then we have 1, 2. Similarly, how many? Say 24W. And then 1B. Then say 14W. So they will be converted into respectively 12W, 1B, 12W, 3B, 24W1, 1B, 14W. So got it? So this is 12W. So that's why RLE will convert it to 12W. This is 1B. So 1B. So again 12W, 12W, then 3B, 3B, and then 24W. So 24W, 1B, 1B, and then 14W. So through RLE, we'll get the code like this. So this can be interpreted as a sequence of 12Ws, 1Bs, 12Ws, 3Bs, like that. Okay, you got it, how the RLE is working. So try to write the steps. Okay, so the run length encode represents the original 67 characters only in 18. Okay, so that's the advantage of it. And we'll apply only when we'll have a repetition, means there are many number of runs. So I hope you got what is run length encoding. So coming to today's question is explain run length encoding. So this means you are going to write the steps involved in run length encoding and do comment it. So guys, that's all for today. Take care. Bye bye.